Hey everybody, this is another episode of Ask an Anthropologist About Worldbuilding, and I'm here today with a very special guest, Dr. Dakotah Tyler. Dr. Dakotah Tyler is an astrophysicist, author, and science communicator who studies exoplanets and the search for life beyond Earth. He creates content that makes the universe accessible to millions online and hosts the Dr. Starkid Podcast, which is really excellent. You could find it over on YouTube. He's having some great conversations over there. Also, as I was saying to him before, he's got so many great shorts that are easy and accessible for you to really digest a lot of these tough concepts in astrophysics. Because I don't know
Yeah.
about all of you out there, but my physics is a little on the rough side. So as
Yeah.
much as I
Thanks.
love that stuff.
Thanks for the intro and thanks for having me. Excited to
Yeah,
be here.
yeah. So tell us a little bit about your background. How did you get into astrophysics? Physics? What was your draw?
So I actually used to play football. You can actually see my college helmet back there behind me. And I got injured. And when I was injured, I was like on the couch after a surgery, one of the surgeries I had, and I started watching astronomy documentaries. And that's when I learned that there was like all these other planets out there that were orbiting other stars. And that was very captivating for me. It wasn't really something I had ever thought about before. And I think not being able to play sports when that was such an important thing for me opened up my mind to being influenced by the exoplanets, which is what I ultimately ended up getting my PhD in, studying planet atmospheres that orbit other stars.
That's so. And why study atmospheres?
Um, well, an atmosphere is as much of a property of the planet as anything else that you could think of in terms of something that is critical about the planet and your understanding of it. For example, one thing that may be critical to know about a planet is how massive it is, right? That tells you something about how much gravity is there. Or you may want to know if there's like liquid water there, right? Because that's cool for some life-based reasons. Or you want to know if that planet has, a bunch of volcanic activity or something like that. And the atmosphere is just like another critical component on a planet to help you understand something about it. For example, we have 4 rocky planets in our solar system, and they all have like varying degrees of an atmosphere, which renders each one of the planets completely different, right? Mercury basically has no atmosphere. So, the conditions you encounter on Mercury are like not unlike the conditions you encounter on the moon, except it's way closer to the sun. So, it would be hotter. But then you have Venus, which does have an atmosphere, but the atmosphere is so thick that like we would be crushed if you were standing on the surface of the planet. Then you have the Earth, which has way less of an atmosphere than Venus, but way more of an atmosphere than Mars. I think Mars has like 1% the atmosphere that we do. So, if you popped open a bottle of water on Mars, there's not enough atmospheric pressure for it to stay liquid. It would like boil and freeze. And so understanding the atmospheres of planets, it's like, as fundamental as understanding the most basic thing that you could want to know about another world, especially if you're thinking about do these things have life? Like, how does the atmosphere evolve over time? And that's what I studied specifically, was how planet atmospheres evolve, like how they change over time.
That sounds absolutely fascinating. So have you encountered any planets out there that have atmospheres for potential life in your
Oh,
studies?
no, absolutely not. I don't even think we've encountered small planets that have any atmospheres. But I think it's more of a detection issue for now. So a lot of the planets that I study were more massive. So like hot Jupiters, sub Neptunes, and these planets we can detect the atmosphere because there's a lot of it, right? There's like a substantial amount of the mass of the planet is literally gas. So in a sense, the planet is mostly atmosphere. But when we think about life, the atmospheres that we have in our solar system, Venus, Earth, and Mars, we actually don't have the sensitivity to detect those yet. on similar planets in other solar systems.
So you're only really going to get into the gas giants just because of size. Is that correct?
Yeah, there's so much more atmosphere that it's easier to detect, basically.
Well, I guess you have to start with the big stuff and work your way down when your instruments get more sensitive.
Yeah, and that's exactly the process, the sequence.
What's your favorite besides exoplanets? Because obviously that's your favorite. That's how you work in academia, right? You're not going
Mhm.
to write several hundred-page PhD on something you're not very invested in. But
Right.
what other topics in astronomy do you really enjoy?
Besides exoplanets and um like astrobiology, I guess I'd probably say I think cosmology is interesting, thinking about the universe starting or at least like going through a beginning of our current space-time and thinking about how the universe itself evolves over time. And I guess at the ends is the most interesting to me. What happens at the end of that evolution, if there is an end,
Hmm.
and then what predated or kicked off the beginning event, the expansion that started happening. Like, what was that? Was it what you would expect if there was not if nothing existed? Is that something you would expect, or is there a bigger multiverse that we're a part of, or is it directly tied to like the death of another universe, or was it like a big crunch thing and then the universe just goes through these cycles of rapid expansion and then rapid crunching contraction? And so I like cosmology because it's like it takes it to the next step. You study anthropology and you start to figure out why human civilization is the way it is. You like understand how we develop technology. And you study biology and you start to realize that humans actually evolved from simpler things and like life started at some point. And we know how the earth was formed and we know how the sun is formed. And we even know how the galaxy is formed, but we don't know like how the initial event, the universe itself was like begun, if it was begun.
Yeah.
So cosmology.
Yeah, and certainly there's plenty of science fiction that tries to play with those ideas, that's for sure. Um,
Yeah.
which is always fun. I mean, so much of science fiction has either imagined possibilities that were dead wrong or like pointed to
Mhm.
things that actually had some sort of validity behind it eventually.
Have you ever read The Last Question by Isaac Asimov?
I've not read that Asimov book. I've read a bunch of his, but not that one.
Super short story. It's like maybe like a 30-minute read or something like that. And it's very interesting. And it's one of these, like, it's kind of like, where did the universe come from question. And I thought, and it was written, oh my God, like almost like 60 or 70 years ago or something like that. And it feels very relevant even to today. But that anybody listening, The Last Question by Isaac Asimov, I think is a great read in that vein of sci-fi starting a universe type of thing.
Very cool. It'll definitely be on my to read list. It's maybe even tonight.
Yeah, it's good. It'd be worth it.
So our next section is your bones to pick. So when you watch fictional universes, what as an astrophysicist really kind of like get under your skin in terms of like very misinformed kind of world building?
That's a good question. I think that the most obviously just completely botched and exploited right now is this multi-dimensional thing where like you go to a different universe where you're wearing a different colored shirt, or where somebody never existed, or everybody is Legos or something like that. And I think it's kind of interesting, I guess, in a storyline way, but people actually believe that there's like these other universes with versions of us. And it really comes from this mini worlds interpretation of quantum mechanics, which doesn't say that exactly, right?
Mhm.
um So in quantum mechanics, it's like, things can exist as waves and particles, but it seems like it collapses to a particle when you measure it. And like, why is that? How come you never measure it being like all of these things that are possible? Why is it always one? And so the many worlds interpretation says that, well, actually what happened is every single possibility does exist. You just happen to be in the universe where you measured it in that state. But there is also a universe for every other state. Right? So the multiverse in this framework is not when you put on your clothes this morning, you chose a black shirt and the other version of you chose a red shirt. It's like the electrons that are somewhere were in spin up state instead of spin down. It's like it's not related to decisions that people are making or falling in love or like going to this school instead of that school. It's literally about like this quantum state that electrons are in, or some particles. So the difference in that other universe wouldn't necessarily be that this other person became a rock star, the other version of you. It would be like that other version of you had an electron that was in a different state in that moment.
Okay.
Right.
Yeah.
And so that
I just finished I think 7th book in the Old Man Wars series by John Scalzi, and they have a system called a skip drive. And the skip drive is how they beat the faster than light problem. And what it does is it puts you into a reality where like another electron had a different spin. So you're actually traveling to kind of another universe. The 7th book, someone invents like this really powerful and advanced alien species, invents one that you can go further away in probability. But like most of their traveling is like technically they go to a different universe that has like one electron in the whole universe that is a slightly different state.
Yeah.
And that's how their FTL system is. So it's just kind of interesting to hear you bring that up, because I was like, oh, I just read about that in Scalzi's work.
Yeah. No, so that's cool. That's a universe that like did world building the right way. Now I get it in like a movie, it's not, I don't think I don't know if it's like worth it to get down onto, get into the nitty gritty like that, but that's very cool that people are taking that into consideration for sure.
Yeah. Well, he does a lot of really, and most of his stuff's like light and humorous, and it's I mean, he wrote a book called like the Kaiju Preservation Society, where they like go to another world and all the kaijus are there, and that's where they come from. Sometimes they leak into our reality, sort of thing. I mean, it's just absurd. They're having to basically change Godzilla's diapers and stuff. I mean, it's like they're pretty funny and ridiculous. Yeah. Well, that's certainly certainly something for all of you to consider for your world building. Is like, is this many worlds thing really a many worlds thing, or how can you play with that in a different way? But let's open it up to questions. I don't have any in the chat just yet, so feel free to put your questions in the chat. I do, however, have a series of questions from across social media. The first one is from Screaming in the Void off of Reddit. Is the Earth unusually small for a planet, or are we biased towards seeing only larger exoplanets?
That's a great question. We're definitely biased towards seeing larger planets. However, we are good at detecting Earth-sized planets that are close to their stars. So, although I would agree that we could be missing tons of even smaller planets, like Mars-sized planets, like maybe Mars-sized planets are actually the most common, and we just can't find them because they're a little bit below our detection limit. But for super Earths and sub-Neptunes, which are the most common planets that we find, which also we don't have either one of those in our solar system, which is interesting. I would say that we're not far off with the number of close-in Earth-like planets. However, with the caveat that we're definitely better detecting bigger planets because bigger things are easier to find, basically. But we're also not good at finding planets that are further away from their star. And Specifically, as the planet is small and gets further away from its star, it becomes right now impossible to find. So there could be, it's a possibility that Earth-sized planets rather are extremely abundant, but at like Jupiter distances or something like that. And that is just not something that we can find. I mean, even at 1AU, we don't know of a single Earth-sized planet at 1AU around a sun-like star. We've never found one. We've never found an Earth analog. All the Earth-like planets that you hear about are much, much closer in. Oftentimes they're on orbits that are, only like somewhere between 5 and maybe 70 days. So way, way, way closer to the star. Again, because it's easier to find when they're closer to the star. So it's very likely, or I would say it's very possible that there are far more Earth-like planets that are just a little bit further from their star that we're not privy to yet.
So to clarify, how exactly do we see an exoplanet? Like, is there some detector? Are you looking for gravity waves? How does the process of finding an exoplanet work?
That's a good question. There's a handful of ways to do it. But right now, the most successful way, the way that we find the most planets, is by taking a dedicated satellite, a transit satellite, and just doing a survey. So like staring at thousands of stars constantly for days, weeks, months, and waiting to see any of those stars just dip in brightness a little bit. And then if you start to see periodic dips in brightness, then you're like, oh, so every 10 days, this star gets dimmer. And it happens exactly at every 10 days. It never like skips one. It never like halves the cadence. It's just every 10 days. So you would infer there that there's a planet that's orbiting around and blocking some of that starlight every 10 days. And then the fraction of starlight blocked will also tell you how big the planet is. And so this is called the transit method. And it's the way that we have confirmed the most planets. But there's several other ways as well. They just are either more difficult or require far more observations than what the transit surveys do.
Well, it makes sense too that you can't see stuff that's farther out because the orbital period would be much greater. So you'd have to be, I mean, like, what is it? How long does Jupiter take to orbit the sun?
It's over a decade, right?
So you have to point the telescope for a decade to see it.
But also because it's so far away, the chance that it crosses in between you and the star also decreases, right? So, you think about if my fist is the star here and the planet is close, it's like the planet could be inclined down here or up here, and it's still going to block out some of the light. But the further and further that my finger gets away, the like more perfect it has to be. Like going up or down, you'll miss it. So this is another reason that we're so biased towards close-in planets. It's not just that you'd have to be staring at Jupiter for like 30 years to get 3 or 4 dips in light, but it's also that it's like almost impossibly unlikely that a distant planet like that will be aligned perfectly so that you can actually see it. It's much easier to block out the light when the planet's close.
Okay. And how many approximately exoplanets have we confirmed at this point?
I think the number is somewhere around 7,000. There's this website called NASA Exoplanet Archive. I used to use it all the time.
NASA Exoplanet
when I was in grad school. So it looks like 6,336 confirmed. But there's another 8,000 candidates. So these like maybe after some more observations, they may be confirmed. And I think with Gaia, which is a telescope that also gets observations, it may add tens of thousands of planets within the next couple years.
Wow.
It remains to be seen, but right now the number is 6,300.
I mean, I feel like it wasn't. It was only like the 20 aughts that we found the first one, right? It wasn't that long ago, was it?
No, 95 was the first hot
Okay.
Jupiter found around a sun-like star, but in 92 they actually found some of the weirdest planets, in my opinion. They found planets orbiting a pulsar, which is what's left over when a star explodes.
Mm-hmm, mm-hmm.
And they found these planets that were orbiting that, and it made, it has like forced people to rethink planet formation, because like maybe after you explode a star and like vaporize everything, there's like another round of planet formation that can happen. But yeah, 92 was the first planets. 95 was the first planets around a sun-like star, and not a pulsar or a neutron star. And then yeah, I mean, we've been off to the races since then.
Yeah, there was that. I think it's Robert Forward. He wrote the book Dragon Egg, and it's about they find life on a pulsar, on the surface of a pulsar, and it's a really they're very like very tiny, and their lives are like a day for us is like a decade for them, and it was a very
Interesting.
very interesting approach for world building, but definitely fun ideas to play with.
Yeah.
We have one from Aisha on Substack. I'd like to build a zero-G world. Beyond watching videos of astronauts, what are some good sources of information to help me picture how various daily activities might work?
What are some good, sorry, say that again. What are some good activities for what?
So they want to build a world that's all zero-G. So it's a fictional
Yeah.
world that's zero-G. What are some like sources or information that they can help picture what life would be like living 100% in zero-G? Besides
Like
NASA.
On a planet?
I does not say. Let's assume on a planet, but that
Well,
wouldn't make much sense because they have
right.
gravity.
Right, because that's what holds the planet together. Literally, is the gravity.
Mm-hmm.
I mean,
Maybe a
I
space
don't.
station.
Okay, so life in a space station and like resources for where. I mean, I don't really know. There's been quite a few medical studies that have been done on astronauts that will tip you off to the fact that the human body is definitely like not designed to be in zero G. But some of the things, if you think about what the astronauts have to do when they're in space, is they have to like work out for 2 or 3 hours a day to keep their heart healthy and their keep their muscles from atrophying too much. But yeah, I don't really know of a resource for that, but I feel like you could get a lot of information about environments that you could create, problems that may arise, or like somehow just infusing your world with the information about what we have learned from astronauts going and coming back from space over the past several decades of the space programs. And I mean, those papers, I mean, you could probably look them up, but I really can't think of another resource besides that, right? But just thinking in general, it's like, why, how are our bodies designed? Like, why do we need a heart that pumps blood? Well, it's because we have gravity, right? And if you didn't, like, all your blood would just want to go down to the bottom. So your heart has to pump against gravity to like get the blood moving up. The entire reason that we have muscles at all is to move around on a planet that has a lot of gravity. So thinking about world building like that, okay, so you don't necessarily need things that need to have like dense or strong muscles if there's no gravity. Maybe you can accomplish the same sort of motion with minimal effort. And then so like maybe I don't know if the life forms are like people or something else. Maybe they can put so much more evolutionary energy points, if you will, into developing something else. I don't know like what that would be, but
a question for you though, like a follow-up question of that, like would I mean, obviously you can get taller in less gravity. I know that just from reading all kinds of hard science fiction over the years. Um, but could you essentially have like very large creatures if a planet had very low gravity? Does that become more possible? I mean, I know we have like the dinosaurs, which I know there's a lot of speculation as to how they were able to get I know there was an oxygen question for a while, but now I guess it's been challenged. But like,
Mhm.
could you have a massive like jellyfish that took up the size of like, I don't know, like a large ocean that was just hovering around in the atmosphere because you had lack of gravity? Is that any at all realistic?
I mean, that's an interesting question. I think that when stuff gets big, you run into other problems.
Mm-hmm.
Like, yeah, you wouldn't have to, like, what is it doing? Is it doing something? Like, is it competing with like other animals or with other life forms? Does it have predators? Because there's a lot of expense to being
Right.
large, right?
Yeah.
Even if you think about in the ocean where um you can kind of get like as big as you want because you don't have to walk around. That's why the largest animal that's ever lived is alive right now, the blue whale. And but that's still they still eat a huge amount of food, right?
All they
And
do
they're
is eat.
eating, that's basically all they do. And
Yeah.
it's krill. So it's not like they're hunting big things that are hard to find, but you have to like constantly be finding some source of energy, of food, of sustenance to fuel having that enormous body size. But that's like, I mean, that's one thing that could happen. Many other animals in the ocean, went a different way
Mm-hmm.
where they, don't eat as much food, but they're smaller and they're faster or something like that. So I think that's interesting. It's an interesting question.
Um, and I do know, so more follow up for this. I love the Expanse series. I don't know if you've read that one or watched the show or whatever.
I watched the show. I haven't read the book though.
The books are even better, if that's even possible, because the show is incredible.
Very
But I
good.
do
Yeah.
know when they get injured and they don't have gravity, it's a real problem. Is that a real thing? Like if you have a wound, do you have real issues with like internal bleeding and bleeding to death because there's no gravity?
Yeah, that's a good question. So you think about what even helps us heal when we get hurt. It's like the circulation of blood, right? It's like the blood flow, getting new blood in there in a certain part of your body helps because you're getting like new blood cells that have like platelet, whatever it is. It has to do with blood flow. But you ever see the astronauts when they're in the ISS and they're doing something and it looks like their heads are about to explode? Like it kind of looks like their like blood is pooling in their head or like their
Yeah.
veins are popping out or something. Well, that's just because without gravity trying, like keeping blood going in a certain direction, everything is kind of trying to expand inside of you, right? And so you're not getting normal blood flow when you're not on gravity or I'm sorry, when you're not on like 1G of earth gravity. And it has to do with the fact that our bodies have like our ancestors developed this ability to heal their injuries while walking around on earth.
Right.
And so when you change that environment and you change up like the way that the heart is functioning or the heart is becoming weaker, so it's not pumping as much blood, then you're not getting, and who else, who knows what else changes? Maybe the like the molecular signal that gets triggered to heal is not even capable of doing so when you're not in an environment with the same amount of gravity. So there's so many things that can go wrong for the simple fact that we evolved on a planet with gravity. But if you evolved somewhere where there wasn't gravity, um, then I would assume that would be different. That wouldn't be an issue.
Like tardigrades?
Hmm. I don't know. I mean, tardigrades, I think they can survive extreme conditions because they go into stasis.
Mm-hmm.
I don't think that they're actually Like I think a tardigrade could have survived the vacuum of space, but I don't think it's doing things. It's not like
Just in a little shell.
going up. Yeah. It's like in this little, like a little, I forget what the term is, biostasis or something like that.
Yeah, there's a term for
Cryptostasis.
yeah,
Cryptostasis.
it's when like even like little, well, like the whole cryptosporium virus that's going on right now. The reason it's so hard to deal with is because it like goes into a tiny little hardened ball when it's not.
Yeah.
That's what makes it so persistent and a pain in the ass.
Yeah.
Let's see. We have one. How should we handle astronauts encountering alien microbes and bacteria for the first time?
That's a great question. And that question, first of all, has guided the thinking behind the Mars sample return. So we have a couple rovers that have been on Mars for a while. I think our first rover on Mars was a couple decades ago, maybe. And some of these rovers have been collecting rocks. And one of them in particular, Perseverance, I believe, last year, it was either Perseverance or Curiosity, found what looked like evidence of past microbial life. It's what it looked like on the surface, right? When you see that on Earth, it's a sign that there was some bacteria doing some sort of metabolism. But you really need to test those things. So we kind of like want to get those samples here. So they're trying to plan a mission to get them back. And when you think about something like that and not wanting microbes from another planet, for example, like maybe there are microbes in the, inside of the rocks or something like that haven't, that are still alive, then you want to be able to contain it. So they have to design this laboratory that is like a two-way lab. Because sometimes you don't want anything getting in. Think about like a clean room for NASA, right? Like they're making these mirrors that are like perfect down to the atom, and they don't want a piece of dust in there. So you keep everything from getting in. And then sometimes you want to create your lab so that nothing can get out. Think about like medical testing or something like that. But in this case, you kind of want to do both things. Like you want to design something that doesn't let anything in and that doesn't let anything out for that reason. So, I mean, the danger, I think, ranges from something that immediately is foreign to your body and you'll die from, to these things being so different from one another because they have different origins and, evolutionary histories that they almost can't interact, that they can't do anything. Which is interesting. And it's like, it's such a wide range. It's like, oh, it doesn't really matter, to, oh, this will kill everybody on Earth if it breaks out, or it'll like, kill all the microbes on Earth, or whatever the case is. So I think that there's not a lot to worry about for now, because most of the, bacteria and microbes that astronauts come into contact with are like stuff that somehow sneaks into these places and then survives and then evolves and changes. But we're not really going to other places where like alien life forms are being interacted with or contacted.
Yeah, I know. So Kim Stanley Robinson wrote a book called Aurora, which is about a generation ship. I don't know if you've ever read that one, but
No, I haven't.
But it's really like the scientific problems of building a generation ship. It's unfortunately kind of a dismal book in a lot of ways, but they finally get to this other world 120 some years later, because I think they were traveling at like an eighth of the speed of light or something. Is the fastest they could get the ship to go. And they get there, and the one guy, like, they finally takes off his suit, and there's like a prion disease there, and it just kills almost everybody. It's brutal. Sorry, I'm spoiling this book for you guys. That's only in the middle of the book that happens. So there's a whole sequence of events that happens after. So I'm not ruining the whole thing, but
and thinking even about these. So you were talking about the prions. They aren't even living. They're not. They don't even have an encasing around them. They're literally just like proteins that have been folded, and when they touch something, they immediately cause it to like misfold in the same way, and then it touches something else and cause it to misfold in the same way.
Yeah.
And that's what mad cow disease is. It's
Yep.
it's a brain prion disease of cows. Yep. And it's not a living thing. And so I think that sort of thing is almost even scarier, right? Because that's not even life. Mm-hmm. Like a prion is not a living, it's less alive than a virus.
It's an ingredient of life. It's
literally like, it's just a thing that could be anywhere. And so you may ask yourself, well, how many other molecules like that exist that form maybe on a place that never had life? Mm-hmm. And they're just like these, there's like some molecules like that.
Yeah.
Crazy.
Yeah, and could really wreck your whole fictional world.
Yeah.
Right. Yeah. And like I know in the book they had a hard time dealing with them because they were like, they're so small, because it takes them they can't figure out why these people are dying on the planet, because only some of them go down to the planet, right? Because they're trying to figure out, is it safe or not? So it takes them a while, and they finally figure out it's a prion disease. And then they have like something that's called like a viroid as well. Or maybe that was a different book. But the viroid, which is like 2 steps up from a prion, but not quite a virus yet. So it's like halfway to life, but it's not full life. So certainly it's interesting to think about. But I think that 2-way lab, could you... do we have any examples in the world of a 2-way lab that someone might look for world building?
I don't know of any specific examples. I want to say that this is a bit unique. Like in general, you want to be cautious no matter what your lab is, especially, if you're doing medical treatment or like medical research or something. You definitely don't want anything to ever get out. But I don't think that the same requirements are on you in terms of getting in, like at the level that we're talking about for this sort of situation. So I don't know what a good lab there would be. I happen to know this guy, Alvin Smith, who's he works for NASA, and he was a part of the planning for this Mars sample return mission. And this is one of the things he was telling me about, was one of the big challenges, is that they kind of they're going to need to invent, and I say they were going to need to, because this got cut in the NASA cuts, earlier this year, last year, unfortunately. But he was saying that they were going to need to basically invent a new one that was combining the level of security that, and level of caution that we would need for this 2-way lab. But I feel like a good place to start would be whatever the most secure, medical treatment center or medical research lab is.
Yeah, probably. I mean, CDC has probably got some pretty intense stuff, especially dealing with Ebola. And, I know they have, I don't know if they really have smallpox, or that was just like a conspiracy theory thing, but I'm sure they have at least the DNA on digital form or something there. But
you can think like a cool idea, just to, because somebody asked the question, a cool idea maybe is like something that, just to have for a cool sci-fi situation. Maybe it's like you walk through into this inner contained lab, and there's like a giant vacuum chamber that kind of like insulates it. So, you would never be exposed to that vacuum chamber, but when you're in the thing, there's like a vacuum chamber on the outside, and then, the rest of the building is beyond that. And maybe like something like that would be cool to play with.
See, but also, like you say, the funding gets cut for that kind of thing. But like even though we might not need that thing specifically for any reason on Earth at the moment, there might be a circumstance down the line when we would need a clean room, containment room like that in the future, and it's space travel that gets us there. It's like all these things that we do for space. Then, and this is why I get a little irritated when people are like, well, what are we doing stuff in space for? It's like, do you not realize how much of our modern life is based off the technology that came from NASA?
Yeah, it's and it's a hard thing for people to get because these aren't like predictions that are made. I think there were some nuclear physicists that were running experiments, and they ended up discovering the technology that MRIs use, right? And it's like, right, how many lives have MRI saved? Well, the funding for that was not from medicine. It was not in the hopes that we discover something that would help doctors look into your body without having to cut you open. It was just like a thing that was very useful when we understood this new thing about physics. And yeah, there's like so many examples of that in things that are NASA related or just like space related. And they're like surprises that end up being very practical and useful in other areas.
Oh yeah, for sure. Let's see. We have one. So this one is, how far away would an alien civilization have to be for us never be able to detect them, even with our best current instruments?
Ooh, now this is an interesting question because I would say pretty much anywhere. So we'll like work through a progression. For starters, let's say any other galaxy. Like, because when we see galaxies, you can like see the little fuzzy thing, but what you're seeing is like that entire 500 billion stars.
Right.
So it's like you have no hope of resolving a civilization or a planet or even an individual star. Like, it's very hard to even see an individual star. Okay, so we'll get rid of every other galaxy. Now, within our galaxy, it's interesting. We have limitations because of our just instruments that we use now, but it depends on what you want to look for. If you can convince yourself that there's life on a planet because the planet has oxygen, carbon dioxide, methane, H2O in its atmosphere, then this is something that we could probably detect on planets within less than 1,000 light years, to push to the extreme. But that's not necessarily evidence that there could be life. There's oxygen existed way before life existed. Carbon dioxide is on, most of Venus's atmosphere is carbon dioxide, and there is no life there that we know of. Methane too. It's like Titan, Saturn's largest moon, has entire oceans of methane. That doesn't mean that there's life there. So all these things can exist abiotically, like without anything to do with life. So if you want to get more specific, if you want to get like more hard in your evidence and in your proof, then I think you drastically close that gap and you start having to look for technosignatures. Like, this is something that is producing either electromagnetic radiation like radio waves, or there's like something that's happening here that cannot be explained naturally. When you're talking about detecting this technosignature, you're kind of talking about things that are extremely close to be able to have like that fine of a detection. Because as a radio wave, for example, gets further and further away, the signal gets weaker and weaker. It gets harder and harder to detect. So, one thing that we did is we took this giant radio telescope in Arecibo, Puerto Rico, and we like beamed a message that could not be mistaken for a natural thing. It was like very unnatural. And we beamed it at a star cluster that's a few dozen, like tens of thousands of light years away, but still in the Milky Way or something like that. And like they'll get that signal one day because we tried really hard to create a really powerful signal and beam it directly somewhere. But that's intentional. And so I feel like for us to detect a technosignature, it's gotta be really leaning towards them, like somebody sending a signal for us to detect. And then for me,
Contact.
that would, like a very intentional signal. And so that like drastically closes in what I think would be a reasonable like radius from us. Although You know, you could imagine trying to send one halfway across the galaxy from a civilization that did it like, 40,000 years ago or something, and we happened to see it at the right time. But then it's like, you don't know if they still exist or not because it was from 40,000 years ago.
Yeah.
So that's a tough question. But I think that if you think about those different aspects, then it kind of changes the what you may or may not think would be possible.
Mm-hmm. Yeah. And I mean, of course, we've been looking for life at our own solar system, and so far, I know there's possible signs, but no confirmation. Which kind of brings to the next question. What does the habitable zone actually mean? If we have things like tardigrades floating around, how important is the habitable zone for alien life?
That's a great question. And I think it boils down to how important the conditions that are required to start life are to be maintained in order to keep life there. So the tardigrade thing and other extremophiles, you bring up a great point. Apparently, there was this study that came out within the past couple of years where they found these microbes that were in some rock that was underground, and they aged the rock at like 100 million years. Mm-hmm. And they put some nutrients, I don't know what it was, like salt or something, put some sort of nutrients on it, and the microbes came back to life and started reproducing. So they basically went into this like cryptostasis state for 100 million years and didn't die. Like mm-hmm. that didn't kill them. And so, and then you learn about things like tardigrades, and it's like you can live in a volcano, in space, underwater. You can be dehydrated for thousands of years. That's insane. Does that mean that life could be anywhere? And then I think that the answer is that, well, because it's so adaptable, once you get it started, it may be damn near impossible to eradicate. But I still think that you need to get it started. Mm-hmm. And so, I think without Earth being, this rich organic compound chemistry experimental lab billions of years ago, and you don't get that first life, which was probably very fragile. If you think about it, it was probably like the opposite of an extremophile. Mm-hmm. It was probably like fragile and needed specific conditions. And if you give it 3 billion years to evolve, then yeah, maybe it can survive almost anywhere. But if you need those initial conditions, then you have to think about like how many planets would have those? Mm-hmm. How many planets would be Earth-like at a very young age? And to refer back to that Mars discovery, if it seems like there was maybe microbial life on Mars 3 billion years ago, and Mars is literally the closest planet to us. I guess Venus technically is a little bit closer, but basically the closest planet to us, that would make me think that the conditions on Earth may be common in young solar systems. Mm-hmm. Now, the way that the planet evolves may change drastically, but if you can get it started and it can learn to become an extremophile in a few million years or 100 million years, that almost makes me think that if we go digging down the crust on Mars, is there life there now? Like, are there microbes that are down there? And so I think that the habitable zone is still helpful for telling you that at least at some point in time, if the conditions may have been right for, whatever happened on Earth. But to that point, this is also just the life that we're talking about. Mm-hmm. So, and we don't know a lot about, the atmosphere on a planet. If if we had Venus's atmosphere, we wouldn't be where we're at wouldn't be habitable. We would probably need to be like 10 times further out or something. And then it would have like habitable conditions for liquid water. So habitable zone is a good guess. And I feel like it's still nice because it can give you an idea of like whether or not liquid water ever could have existed. But like once that gets started, who knows? Like maybe maybe it doesn't matter if the planet is still in that location. Maybe it could be closer or farther.
Yeah, and it just reminds me of like one of the questions in the Fermi paradox is, are we just a really young universe? Like maybe the universe
Hmm.
goes on for a really long time and we're like the
Yeah.
first developed life, at least in
Yeah.
this galaxy. So it is
Hmm.
like a question of like how long does it take to become an extremophile, and like is it possible that maybe Mars was the first with life and an impact collision with Mars created a panspermic event, right? Or panspermia,
Yeah.
panspermic, I'm not
Yeah.
sure what the word is, but
It's Serbia. Yeah.
yeah. So there's so many interesting questions. Like I'm,
No, it's a very cool question. And your question there, like I think most people, yeah, I mean, probably if you ask you and I, we would say, no, the universe is so big that there's just like there has to be
right.
life out there. And there has to be probably, even if it's much more rare, there's also probably very intelligent life, probably that's more advanced than us. But if we imagine like going back in the time, there definitely would have been a first in the
Hmm.
universe.
Hmm.
And I wonder if you ask them, if we could go back with a microphone, assuming we aren't the first, and ask them, interview them, what do you think about intelligent life out there? You think you're the first species? You think you're the first ones to do it? I almost guarantee they would say, nah, we can't be the first. The universe is too big. Like it's
Yeah.
been around for too long. There has to be more out there. And they would be wrong because they would have been the first.
Right.
So I feel like that is still a possibility, even though I think we tend to kind of write it off as being like, nah, it's the universe is too big. Like there's others that were before us, but we may not. We may be the first. Like that is possible. We may be the first. It's possible that we're the first and last. Like that is a possibility. I don't
Hmm.
think that it's necessarily likely. That's not what I think is going on. But that actually is a physically allowed possibility.
Hmm. I mean, the universe is so vast that anything is possible, right? So, like
Yeah.
that's the thing, and it's just always kind of amuses me to think that like with when I was first learning about panspermia, I don't know how many years ago, 2 decades ago or whatever, probably in my late teens, early 20s, because I was a huge Star Trek nerd and just
Hmm.
love the idea of life on other planets. And it just kind of tickled me to think that like, well, if an asteroid hit the Earth and caused like this life to spread out, then maybe like some sort of tardigrade dinosaur ancestor is out floating in the universe somewhere, ready to land on another planet and reactivate when it hits the right conditions.
I mean, I can't see how that wouldn't, at least even if it doesn't land anywhere, it seems like that's probably true. We know that we are the asteroid that wiped out the dinosaurs, right? Huge asteroid, definitely hit, definitely kicked up rocks and tons of stuff into space. Is it possible that it kicked up a rock that had microbes in it and that rock never landed back on Earth and like is headed out of the solar system? Like that's very possible. You almost can't convince yourself that hasn't happened. Now,
Right.
whether or not it'll survive billions of years of interstellar space and actually land on a planet that actually has water and that sort of thing, who knows about that? That seems unlikely. But
Yeah.
we saw that what was the asteroid that came into the comet, the interstellar comet, I forget the name, that recently came into our solar
Mm-hmm.
system. It's like, so comets and asteroids from other solar systems do go to other solar systems. You know, how often do they land on planets? It seems like there's like just no way that could happen, but it must happen sometimes.
Yeah. Well, and then they have to survive the impact too, right? So
And it
it's like
might be
it's
impact.
a lot
Yeah.
of what ifs in a long string. I
Yeah.
remember being amazed learning about that that the way that they finally proved that the dinosaurs were wiped out by the asteroid, or extremely likely to have been wiped out by the asteroid, was this like northern Canada is where they're finding the sites, because it's so far from the Yucatan Peninsula, and it just really
Mhm.
hits you like the impact of that asteroid. It's like how vast this explosion was, that they're finding
Yeah.
fossilized fragments of animals in Canada near, getting close to the Arctic Circle from the Yucatan Peninsula. So
insane. And then they have it's a cool, I don't know if you've ever seen the picture, but there's that right at that KT boundary in the geologic record, there's like that band that that's found across the entire globe.
yeah.
That is like, it's really, it has like a lot of shocked quartz and like iridium, which is something that is not found commonly on Earth, but is super common to find in like asteroids and that sort of thing.
Do we know why that
And
is? Why iridium is
why,
more? Do we know why iridium is more likely to be found on an asteroid?
you know, if I had to guess, this is not like something that I remember reading about or anything. So just using my intuition, any given comet or any given asteroid is going to probably tend to be heavy, like really dense, because a lot of the asteroids are pieces of like planetesimals that were dense, and they're like slamming into each other and they're getting broken off. And so there's like a lot of chunks out there. So when you see an asteroid, it's like that, most likely that is a thing that broke off from some bigger thing that had the ability to gain mass and like become dense. So when you smash a core, the core of anything is way more dense than the outside. You know, the outside, the crust of the Earth is like silicates and light things, and the core of the Earth is like heavy things. Iron, the heavy, I mean, a lot of the heavy metals in the core of the Earth are decaying and providing the heat that keeps the core of the Earth hot. So I think it's the you know, asteroid and big rocks out in space are really like pieces of broken up cores where there's a lot of dense material that's coming together, basically.
Is that true of our asteroid belt too, as far as we know?
I don't know a lot about the composition of asteroid belts, but I think that it's true. I know that we have a mission going out to visit this asteroid called Psyche, which is known to be extremely dense, probably from observations of how it interacts with other asteroids. And, you know, the idea there, like, why would something be extremely dense? Well, that's, you know, this only makes sense if you have a whole bunch of hot material together and it's hot enough so that the dense stuff can sink to the center.
Okay.
Right?
Yeah.
That's that differentiation only happens if it can like move freely, right? So it can, if it's hot, it can like sink to the center. And then if that thing collides with something, whatever it is, maybe it's Mars, maybe it's the Earth, maybe it's something else, then what you end up breaking up is you have this really, really dense thing that's kind of like the chunk of a core. And that's how we think of it. So it's like, this is probably a fossil of a planet that got destroyed or something like that, or a planetesimal, at least.
Yeah, it's fascinating. We have one final question. It is, what's one scientifically plausible way a civilization could realistically colonize another star system, and what would the time scale look like?
Ooh, that's a great question. Scientifically plausible. Okay. And it's human, or is it human bodies?
I'm assuming human bodies for this question. That's not clarified.
Human bodies, okay. So I guess the only thing that really makes sense to me is kind of an intergenerational ship that is lasting, you know, let's say the Proxima Centauri, closest star to us, 4 light years away. If we can get it going much faster than what it currently could, but still not approaching, you know, like significant fraction of the speed of light, then like tens of thousands of years, like 10, 20, 30,000 years. But, you know, that's keeping people alive for hundreds, thousands of generations, probably, I guess, hundreds of generations on the ship. But there's no reason that you shouldn't be able to do that, right? It's like, find a way to make food or do some sort of farming or something like that.
One of those asteroids, maybe hollow them out.
Yeah. But then you get to the problem. And this is what I think is the main issue, is that, you know, even if we are super lax and afford our future humans with the ability to stay focused for thousands of years and multi generations, and to be able to survive that, physically, mentally, you always run the risk of getting to a place and the planet is like not what you thought, or it's
Yeah.
inhospitable,
Yeah.
or and so it's like, what does it mean for a planet to be habitable? Because like there's no other planets in our solar system that I'd want to live on.
No.
But I would say multi-generational, like tens of thousands of years type of thing.
Yeah, and then there's an ethical question. You're condemning a whole series of future generations to
Yeah.
like be born into what's essentially a prison because they have no choice. Which
Yeah.
this is exactly what the Kim Stanley Robinson book Aurora covers. Is like they
Mm.
managed to get close enough that it's like a century and a half for them to arrive at this star system, which I think was like 12 light years away. I want to say it's Tau Ceti or something like that. But it's like they took all this time, but like they're like 5 or 6 generations down when they arrive, and and so then a lot of the second half of the book is like the question of like, well, the planet is uninhabitable. We can't go down there now. What do we do? So they have to make some really big choices, and then it's like at the same time, life on Earth has so much redundancy. Like if a system fails on the planet, other systems are around to refill that niche. You don't have that in a planned ecological system, which is what makes it so difficult.
Yeah,
So.
exactly. Yeah, and even if like things are just slightly different or go slightly wrong, that can be like something that you cannot fix, or you cannot deal with. Yeah.
Well, and this
Very
massive
interesting.
ship had like every ecosystem represented. They had like an ice area, they had like a savanna area, they had a woodland forest, they had an ocean. I mean, everything you could think of, they had like accounted for all the possibilities. And I think it's like takes place like 200 years in the future or something. So the science is supposed to be better, but it still is not it's not very viable.
Yeah. It's fun to think about though.
It is.
Fun to
And
think about.
what happens if we get there and there's already life? Like that's so many questions you can play with. And that's the fun thing about world building. It gives us a chance to imagine possibilities and complex scenarios and ideas. But one final question for you today. Do you have any particular resources that you think would be useful for world builders who are trying to build a more realistic kind of exoplanet or space travel or anything like that?
Yeah, I think that playing around on the NASA exoplanet archive is actually a cool place to go to learn what we know about planets. And then you can kind of like do your world building around that. So it's like there are links to every paper that basically comes out about these certain planets. You can like search for through the catalog and find weird systems that are maybe like unlike or that are, I guess, unusual is what I'm trying to say. But I feel like that's a cool place. I think still the issues with like astronaut health and what we've learned about living in space, I feel like there's a lot of rich like data and revelations around that as well. So I think those are probably the two that come top of mind.
Yeah, and I mean all that stuff is free, like free resources for us. It's I've used the NASA site for quite a few things over the years, and it is they do a pretty good job of making it very searchable. So it's definitely very useful. But thank you so much for coming today. You can check out Dr. Dakotah Tyler's work on the Dr. Starkid podcast, which has some really great episodes, ton of fantastic shorts. There's so much rich content and material. Like your own site is very much a resource for world builder. 100%. Like there's a lot of stuff on there, and you cover a lot of stuff even beyond astrophysics, like just basic like science stuff, which I think is
Mhm.
really useful. So great
Yeah.
resource on your site. For all of those of you out there who don't know, I just launched my brand new YouTube series, Anthropology Through Science Fiction. So if you're looking to try to dive in on social theory and it's really complex, but you want something grounded in speculative fiction, I just launched the first episode yesterday, so you can check that out. And as always, you can come to this show for world building resources. My website has a whole series of world building resources, and our book, Build Better Worlds, An Introduction to Anthropology for Game Designers, Fiction Writers, and Filmmakers. Next time, we will have a specialist in textiles, the anthropology of textiles. So if you have questions about clothing and environment, this will be a great episode for you. Thank you again so much, Dr. Tyler, and we really appreciate you coming on and giving us some of your time.
Yeah, thanks. This was awesome. I love talking about this stuff. Appreciate you having me.
Thanks so much.
Yeah. Take care.
Okay, stream's done.